Alright, now let's talk about some continuous graphs. Alright, let me just draw a graph template really quick. Here you go. And then let's make our equation just a simple one. Say y equals x squared. And this is going to be a continuous graph because it will always continue. When we draw it, it's going to be like this, somewhat like that. It's going to have arrows on both sides, which means it's going to go all the way. It will never stop, so it's continuous. That is continuous graph. And then let's look at a non-continuous graph, just for example. A non-continuous graph would, let's say an equation would be y equals x squared, but let's just say it has x is only greater than 5. That would not be a continuous graph, as it would be, let's just draw it over here. It would only be over here. It's not going to continue, it's going to stop right here, but it's going to go over there, but it's going to stop right there. So it's not going to be a continuous graph. Alright, let's talk about some boundaries here. Boundary on a graph would be like a bounce on like a cosine graph, so let me just draw it for you guys to better understand it. Alright, so let's just say our graph that we're going to draw is y equals cosine x. And the cosine x graph will go like this. And this right here, this and this right here on a graph, those are called boundaries on a graph.
Now we're going to talk about domain and range. So let's just draw a simple linear equation. And in this, you've got a domain, which is the x numbers being all reals. And you've got range, that's also all reals because it extends to infinity in each way. But if we do something like quadratic, the range would be only greater than 0, since it cannot go below this y equals 0, and the domain would still be all reals.
Today we'll be looking at x-intercepts and y-intercepts. So what are they? X-intercepts are where the y-coordinate is equal to 0 and they hit the x-axis. Y-intercepts are the exact opposite. It's where the x-coordinate is equal to 0 and it hits the y-axis. So here we have a graph of, or equation of x squared minus 1. So we're going to draw this equation as a regular parabola. And as you can see, here would be our y-intercept because it hits the y-axis. Here would be our x-intercepts. So what are these? So our x-intercepts would be -1, 0, and 1, 0, because that's where they hit the x-axis. Our y-intercepts would be 0, -1, because that's where it hits the y-axis. So another topic to discuss would be symmetry. So symmetry can be seen in graphs like these, where you can flip the graph and it will equal the same data points. So here we can flip the graph over the y-axis to equal the same graph with the same data points. An example of a line without symmetry would be I have no idea.
It'd be an exponential.
Okay, what is that?
Should I stop recording?
Exponential.
No, we can just cut this part out. What?
Exponential.
Okay, that's the one that goes like this, right?
Yeah.
Okay.
Alright.
Would be an exponential graph. As we can see here,
I can't see.
shoot up like this, okay? And we cannot flip this over anything to equal the same data points. Therefore, this is not a graph of symmetry.
In behavior of graph and increasing and decreasing points of the graph. So first, we gotta draw our graph. Alright, so as you can see here, the in behavior is pointed out by the arrows. So here, when x is approaching infinities, y is approaching infinity. And here, since it's going down, as x approaches negative infinity, y would also be approaching negative infinity. So then here, increasing and decreasing points, this part of the graph would be increasing. Since from down here to there, it's increasing. And then also here, between here and there, it will be increasing. And then at this point right here, it is decreasing.
Another one of our terms is horizontal asymptote. So this is where the x values never go above or below a certain point. So say in this function right here we have, this is our function. So the asymptote would be right here because no point on the function goes above or below that, or no, below this point. It never crosses it. Alright. Now we need to do vertical. Okay, so with vertical asymptotes, it's kind of the same thing. It's where no point on the function crosses a certain point on the graph. So for this function, say we have so our asymptote would be right here because no point on either part of the function goes across or past this section or line.